In this video, I'm going to walk you through Lesson 6 of Unit C1 from Open Sci-Ed. Okay, so we just were introduced to two design solutions in Lesson 5. One was the microbead solution, the other one was the berm solution. So we're going to go a little bit deeper into thinking about the microbead solution in Lesson 6. So we navigate in by looking at a slide, and on this slide, it talks about what the microbeads look like. How can we test specific ideas about these microbeads? You can see they're very, very small. It almost looks like a powder. And here you can see we've got this little patch of ice, and the left side is covered with microbeads and the right side is not. And so we're starting to think, how is this system, how are these microbeads helping reduce that ice melt? They're both white. What's going on here? So this gets us starting to think about light, because light from the sun is coming into the system, and somehow these microbeads are changing the energy transfer that's coming in from the sun. So we use this investigation. It's called the light investigation. And here's a handout. Let me open it up. And you can see that this investigation, students are already being given all the materials and the procedures. They're not planning this one. This is a pretty standard setup. And so you're going to walk through the procedures with students. They're basically going to take two pieces of construction paper. One is black, one is white. They're going to fold it in half 2 times, and then they're going to staple it together. It's going to make a pocket. And you're going to insert the end of that thermometer into the pocket. And then this portion is going to go under a heat lamp. Now, I do talk about this in the materials section. The position of that heat lamp, of course, is going to matter. It should be pointing straight down. So this is going to be something to think about. How can you position these so they're straight down? So what's laying on the table is going to be directly under that heat lamp. I will say be a little careful if your digital thermometers are plastic. You definitely want the envelopes of construction paper directly under the lamp, not the plastic, because it could get pretty hot. We're going to take an initial temperature, and then we're going to take a temperature every 1 minute for 10 minutes. And you can see right here that the thermometers are a little bit out of the direct light. The patches of white and black, those construction papers, are directly under the lamp. Students, after we go through the procedures, are going to have to name the independent, dependent, and controlled variables, at least 2. And then they're going to collect some data. There's room to collect every minute for 10 minutes. So once we're done with the investigation, we're going to discuss the results and complete a KWL. In case you are not familiar with a KWL, it's what you already know, what you want to know, and then after we read an article, what we've learned. And so there's other ways to do this if you're not a fan of KWL, but basically we're going to discuss what we figured out from the investigation, what we know, what we're not so sure about from our results, and then what we want to know. And then we're going to read an article and then complete what we've learned. It basically gives us structure for reading the materials. And so we're going to pass out the light and materials handout. This is going to go over a few different things. One, it's going to introduce visible light and also the invisible light. And we're going to look at this different spectrum right here, the different albedos of different materials. Albedo is defined as, let's see right here, the reflectivity of a material. So we look at different materials and we see that the whitest paint has the highest albedo, and then you got clouds and fresh ice or snow. And then here's the microbeads. So the microbeads have a lower albedo than the snow and the clouds. So that's interesting. That might have something to do with what we're trying to figure out here. You can also see that we have some basic definitions. This should have been developed in middle school, but if not, this is a great time to fill in the gaps. We've got the light coming in can be reflected, it can be passed through and transmitted, or it can be absorbed. So this actually is developed very much in 6.1 of Open Sci-Ed. So most likely you're going to need to refresh memories on this one. So after students have completed the reading, they're going to go back and document or record anything they learned on that learn column in their notebook for the KWL chart. And then we're going to think about what did we learn in our investigation? What did we figure out in our reading that could help us revise our consensus models from lesson 3 and lesson 5? So you want to have these available for students to look at. You can provide them digitally on a learning management system. Just take a picture and upload them to a slideshow, or you can have them hanging on the wall. And then you're going to also need the rules for energy transfer, whether you have a poster or a slide, something where they can see these things as they fill out their handout. Now, the handout is going to ask students to create some energy transfer models, and let's go ahead and take a look at it. So the handout asks, what did they figure out from the investigation? What did they figure out from the reading? And then they're going to use that information with their energy transfer model rules, and they're going to look at this energy transfer model. This one is provided. And this one says, how does energy normally move in Earth systems? We've got the sun that is transferring radiation by visible light into the system. This is our system of our design solution, the microbeads, where we've got, no microbeads yet. It's low carbon dioxide, no microbeads. So the sun is transferring energy into the system. We've got dirty melting ice and snow, which then increases the particle movement, and then energy gets transferred because it's of re-radiation of infrared light to the carbon dioxide, which absorbs it. Now, since it's low CO2, some of it gets re-radiated into space. So this is what they're going to use to kind of base their next two that they're going to develop. And they haven't done this on their own yet. So make sure you point to this one as a reference that they're going to use. And then they're going to complete the next two. So they're going to use what's in here and then adjust it for these two scenarios. This one is high CO2, no microbeads. This one is high CO2 with microbeads. So let's go and take a look at the answer key. And the main thing you're going to point out is that the scenario 2 and 3, they left out the re-radiation arrow from CO2 because it's high CO2. And so it's going to absorb that infrared light. And so they're going to, they may not come to agreement on it. That's okay. But you're going to see that the energy comes in, it's melting the ice, some gets re-radiated to carbon dioxide, and then it gets kind of stuck there. And then in scenario 3, now we've got the microbeads. So the microbeads are actually going to reflect the visible light to space, which means that less of that infrared light is going to the CO2. It still is high CO2. It may not transmit any of that energy to space. It might absorb it all, but look all the energy that already went out from the microbeads. So this arrow is smaller than this arrow. So this is beginning to help students understand how energy transfer plays a role in how the bead solution works. So once we've done this, we're going to revise our class consensus model. This is the model you created in lesson 5. We have some energy transfer diagrams, and we've got, we're really just looking at this top portion, the microbead system. And so we're going to revise this in class, and you're going to ask, well, what kind of things should we do? There's some suggestions right here on some ideas that you can listen for. You don't really need to record these, just kind of trying to surface them from what they put in their handouts. And then you're going to facilitate a consensus discussion as you revise that model. And these are the big key ideas that you're trying to get out of students as the discussion happens. Now, please look in the teacher guide. There's a lot of guidance with prompting questions and answers to facilitate this discussion. But here are the key ideas. Number 1, CO2 absorbs infrared light, but not visible light. Number 2, microbeads on ice reflect more visible light and absorbs and re-radiates less than the ground they cover. And 3, energy that is not absorbed by CO2 in the atmosphere because it's transmitted into space as visible light and does not contribute to that temperature increase because it leaves our systems. So hopefully you're going to kind of get to this with your discussion. And I have to say, if you don't get all the way there, sometimes you give a little bit, you share a little bit. Well, where I was trying to get you is to think about this. So it's hard to get every class to get there where you want them to go. So have a productive struggle, let them try. And then when you're watching your clock and you say, okay, that's enough time and I'm not getting there, say, well, one thing I was really hoping we would get to is XYZ. Sometimes you just got to give it to them. I know that figuring out is what we're doing, but figuring out can take a very long time and you don't always have enough to work with. So just a little suggestion right there. So once we're done revising the consensus model, we're going to make some predictions with a partner about what might happen if we did not have these solutions in place. If we didn't have microbeads or we didn't have the berm solution, what's going to happen? They're going to talk with their partner, share them with the class, and what we're going to figure out is that it's going to get worse and worse. And so we introduce the concept of a feedback loop, which means it's a process that can get worse and worse over time if nothing is done. Now, students are actually exposed to this in B1 in biology, so they are familiar with feedback loops, but it's a kind of a new lens. We're now talking about Earth systems, not ecosystems. And so we're going to add a few terms to our personal glossaries. There's a slide to support you. We're going to add albedo, visible versus infrared light and radiation, and feedback loops. We then update our progress trackers. There is some guidance to help you on this. Again, you can do this under a DocCam and have the whole class follow along if you're new to this, or if students have pretty high functioning with these science ideas, they're really getting it, have them write down their own understanding in their progress tracker. And then they're going to make a claim about microbeads using mathematical reasoning. And so there's actually a handout for this. And so we've got some calculations that we're going to do. If it has this large of an area, we have this much ice, and it's $1 a kilogram, how much basically is this going to cost? So they're going to calculate the cost and make a claim if it's worth it or not. They can also think about other things that are important. And there is an answer key, of course, for your calculation. It actually would cost $1.32 billion. And so probably not worth the cost, but what might also come up is this is going to contaminate the environment. This is going to hurt the animals that live there. So this is not worth the cost of doing it. And then we will reflect on who would be impacted, and that this brings back to the forefront what about the animals? What about the indigenous populations? And so we think about those concerns from the Inuit community members, and then we kind of wrap it up. So this is a detailed lesson about light, but the investigation is fairly easy to conduct. So let's talk about the materials prep in the next video.